I'm going to show you just roughly how we graph position versus time graphs. And we talk about position versus time graphs. This is not a map. This is not where you are as a function of time. Excuse me, this is not where you are on some surface. This is, you're walking back and forth on one dimension, okay? So this x is the position on some axis, on your x-axis. Now notice, when we're graphing, that's the y-axis, that's crazy. But we're talking about in your x position, your horizontal, let's just say, position, this is how many meters away you are from the origin. The origin right here, is position 0, okay, what we're calling 0. In some places, it's a lot of problems, you're not even going to really define that 0. You're really just going to be moving relatively to some initial position. So your initial position isn't this. The origin is 0. Anytime you cross this line, you are back at position 0. So let's just do a sample. We're going to say it starts at position x equals 4. So at the very beginning, you're standing at position x equals 4 meters. At the very beginning, at time equals 0, you're standing at position 4 meters away, and I really ought to have this as positive, show that that's positive. Okay? Time ticks forward. Okay? Time is always going to tick forward. So you walk 2 meters in 10 seconds. So after 10 seconds, you are positive 2 meters away from where you started. Okay? The shape of how those dots are connected could be anything. You could be going fast, slow, you could be going at a constant speed. We're going to assume you're going at a pretty steady rate, and we'll talk more about how we look at the rates in a moment. So you go 2 meters in the positive direction in 10 seconds, and then you end up going 6 meters in the negative direction in the next 5 seconds. So from 10 to 15 seconds, you go 6 meters in the negative direction. If you started that period at 6, you would end up going 6 meters in the negative direction. You'd end up at position 0. And again, we're going to assume that's a straight line. We'll talk about what straight line means in a minute. So there's your total position versus time graph. Where are you at any moment? If we could just take a survey if instead of just this information, if we could say at 1 second, let's stop the clock, figure out where the person is. At 2 seconds, let's stop the clock, figure out where the person is. You can get a more accurate graph. But this is good enough given the information that we have. What we'd really have to say to make sure that this graph is exactly accurate, we'd have to say at a constant velocity or a constant speed, which we'll talk about soon. Okay? The distance traveled, first of all, is probably the harder of the two. In the first part, you traveled 2 meters. In the second part, you traveled 6 meters. The distance is 8 meters. The displacement, remember, change in position, is just the final minus the initial. The final was 0. The initial was 4. You traveled negative 4 meters from beginning. I shouldn't say you traveled. Your change in position is negative 4 meters from beginning to end. Okay? So that's one example of a position versus time graph. Now let's talk about how fast this person was moving. If you walk 2 meters in 10 seconds, let me change the color here. If you walk 2 meters in 10 seconds and then 6 meters in 5 seconds, you went 3 times as far in this part. You went 3 times as far in half the time. So you're really going a whole lot faster. So this is faster. And we can start to make some conclusions about what these lines mean. This was slower. This was faster. This was in the positive direction. This was in the negative direction. Okay, and you can start to see that a couple of things we can learn about this. Okay, so if we have position versus time, positive slope means positive velocity, and we'll talk about velocity, moving in positive direction. Negative slope means you're moving in negative direction. Okay? Remember, this was slow and this was fast. So, big slope, and I'll put this big slope, and I'll put this in absolute value terms, fast. The steeper it is, the faster it's going. So this was fast, this was slow. If we look at a few of these different lines, and it really does not matter what where it starts or where it ends, these are true statements. So if you had a line that looked like this, well, its position isn't changing very much. In fact, if it's completely flat, it's not moving at all. It's staying still. Okay, this is faster. This is faster. Okay, that's also fast, right? Even though it's down there, it's got a very big slope. And this and this and this, or they're moving in the positive direction. This would be moving fast in the negative direction. This would also be moving fast in the negative direction. Let's do one more thing. So if we have x and t and x, if you had something that's going like this, what's happening to the speed? What's happening to how fast it's going? And I'll give you a moment. And the answer is it's going slower and slower and slower. It starts out steep, right? At the very beginning, at t equals 0, can't do that. At t equals 0, it's going very quickly in the positive direction. Then it's going a little slower in the positive direction, a little slower, and then finally at the very end, it's almost flat. So fast at the beginning, slowing down. So it's an object that starts at the origin, is going fast in the positive direction, and then slows down. Think of a ball that you roll in the grass, okay? You roll it in the positive direction. It's going fast at the beginning, slows down, and stops. Think of this. If time kept ticking and that ball doesn't move anymore, it would just continue staying in the same place after it rolled to a stop. Okay? So that's how to think about position versus time graphs.